If I told you that pointing a red flashlight at yourself could heal wounds, stop hair loss, and relieve knee pain, you'd probably think I was trying to sell you something. And honestly, that's exactly the right instinct to have, because red light therapy is everywhere right now. Clinics, gyms, spas, and all over social media. People strapping LED masks to their faces on the couch, stepping into glowing booths that look like something from a sci-fi movie. And the promises are enormous. Fix your wrinkles, erase your scars, kill your pain, and regrow your hair, all from light. So here's what this video is actually about. We're going to find out what's real and what's marketing. Most people assume this is either total pseudoscience or a complete revolution in medicine, but the truth is more interesting than either of those, because some of this stuff genuinely works, and some of it is just expensive mood lighting. I'm going to walk you through the real biology of how red light affects your cells, and then I'm going to give every major claim a traffic light verdict. Green for solid science, amber for promising, but proceed with caution, and red for mostly marketing. By the end, you'll know exactly what's worth your money and what isn't. Let's start at the beginning, because this isn't some trend that was born on TikTok last year. We've been studying this since the 1960s. A Hungarian surgeon named Endre Mester was worried about lasers. They were brand new technology, and Mester thought they might be dangerous, the same way early X-ray technicians had been harmed before anyone understood the risks. So he designed a simple experiment. He shaved the backs of a group of mice, applied a very low-power laser, and waited for the damage. It never came. Instead, those mice grew their hair back faster than the untreated ones. And any small cuts from the shaving healed sooner too. Mester hadn't found danger. He'd accidentally found the opposite. Low-intensity light wasn't destroying tissue. It was stimulating cells to work more efficiently. He didn't fully understand why. But that accidental discovery became the seed of what we now call photobiomodulation, using light to change the behavior of our cells. So how does it actually work? What's happening inside your body when red light hits it? First, a quick clarification. When people say red light therapy, they're usually talking about two types of light: visible red light, which you can see, and infrared light, which is invisible. The key difference is depth. Red light stays near the surface of the skin. Infrared light has a longer wavelength that lets it push deeper, reaching muscle and internal tissue. That distinction matters a lot, and we'll come back to it. Now, when either of these lights hits your body, two things happen. The first is simple, a gentle warming effect. Your blood vessels widen slightly, blood flow increases, and more oxygen gets delivered to the area. It's basically the same thing a warm compress does. Effective, but not revolutionary. The second effect is where it gets genuinely fascinating. Inside your cells, there are mitochondria. You probably remember them from school as the powerhouses of the cell, and that's exactly right. They produce the energy your body runs on. But here's the problem. When a cell is stressed, damaged, or inflamed, a molecule called nitric oxide latches onto a key protein inside the mitochondria called cytochrome C oxidase. And when that happens, it's like jamming a wrench into the gears of a power plant. The mitochondria can't function properly. Energy production stalls. The cell can't repair itself. Here's where the light comes in. When photons from red or infrared light reach the mitochondria, they help knock that nitric oxide loose. The jam clears. The mitochondria spin back up to full capacity and start producing energy again in the form of ATP molecules. So when people say red light energizes your cells, that's actually what's happening. It's not adding something new. It's removing a blockage. It's restoring what was already there. And here's something that makes this even more interesting. Our main natural source of red and infrared light has always been the sun, especially at sunrise and sunset. Scientists believe our bodies actually use that soft morning red light as a biological signal, a cue to prepare our cells for the harsher UV rays coming later in the day. Red light therapy is, in a way, trying to bottle that effect. But this is exactly where we need to pump the brakes. Because what happens to a cell under a precision laser in a controlled lab is one thing. What an LED mask from Amazon does to your face is something else entirely. So let's go through the big claims one by one, and I'll give you a straight verdict on each. Hair growth. The traffic light is amber. The logic makes sense. If red light restores energy to mitochondria, the cells in your hair follicles should work harder and produce more hair. And there are studies showing positive results. So why not green? Because a large portion of those studies are funded by the very companies selling the laser helmets and brushes. That doesn't automatically mean they're wrong, but it does mean they need to be read carefully. Companies have an incentive to only publish results that make their product look good. On top of that, many home devices have such low power that they fall far short of what was used in the lab. So it might help, but probably not as much as the packaging promises. Amber. Skincare. Also, amber, but for a slightly different reason. The same principle applies. Red light could stimulate skin cell regeneration. But the evidence here is even weaker in practice. Most studies are tiny, with very few patients, and crucially, most of them don't have a control group. A control group is a set of people who don't receive the treatment, so you can actually compare results. If I put an LED mask on 10 people and their skin improves, how do I know it was the red light? Maybe they slept better that week. Maybe they drank more water. Without a comparison group, you genuinely can't tell. Take the TheraFace mask, which costs around €350. Their website cites their own study of 115 people showing skin improvements, but no control group. So we don't know if those people improved because of the mask or because they were paying more attention to their skin that month. And then on the other end of the spectrum, I've seen LED face masks in supermarkets for €10. Here's a reality check. A single functional laser diode with the power needed for photobiomodulation already costs around €20 on its own. And that diode only covers a tiny spot. To build a mask that covers your whole face, you'd need dozens of them. If the mask costs €10, it is physically impossible for it to contain the technology being advertised. Do the math. Sports performance. The traffic light turns red. You've probably seen athletes standing in booths full of red LEDs, claiming faster recovery. But here's the catch. The research that actually shows muscle recovery benefits was done with infrared light, the deep penetrating kind, the kind that reaches muscle tissue, increases blood flow, and delivers oxygen where it's needed. Most panels sold for home use are visible red light. That stays on the skin surface. It doesn't reach the muscle. So it doesn't do what the marketing says it does. High-performance clinics using proper infrared equipment? That might help. The red LED panel in your gym? Probably not. Pain relief gets a red light too, for the same reason. To relieve pain in something like an arthritic knee, you need light that can reach cartilage deep inside the joint. Only infrared light can penetrate that far. If you buy a red light-only panel, you'll get warmth on the surface. Your leg will look flushed and feel warm, but the pain will still be there because the light never got past the skin. But here's where it gets genuinely exciting, because I'm not leaving without the green lights, and these are the ones that are actually generating real buzz in the medical community. Eye health, green. Researchers are investigating red light as a treatment for age-related retinal degeneration, the kind that causes vision loss as we get older. And here, visible red light actually works. Why? Because the eye is transparent. There's no skin barrier, no muscle to push through. The light travels straight to the back of the eye and reaches the mitochondria in your retinal cells directly. The results in animal studies are remarkable, and the biological mechanism is solid, green. And then there's the one that genuinely stopped me in my tracks. Blood sugar control, also green. There's a study showing that if you apply red light to your skin for 15 minutes after eating, your blood sugar spike is lower than it would otherwise be. The explanation is almost elegant. We have blood capillaries sitting very close to the skin surface. Red light activates the mitochondria just underneath, and those mitochondria, now running at full capacity, start consuming the excess glucose in your blood as fuel. The spike flattens. Blood sugar drops a little. It's a real, measurable effect, and it's one of the most fascinating things I came across researching this video. So red light therapy is not pseudoscience. But it's also not a magic lamp. The biggest problem right now is what scientists call standardization. Think of it like a cooking recipe. It's not enough to have the right ingredients. You need the right temperature, the right cooking time, the right quantities. With red light, the same logic applies. What exact wavelength? What power level? What distance from the skin? For how long? Every study has used different parameters. There's no agreed-upon standard yet. And because scientists haven't settled on the universal recipe, device manufacturers have no reliable blueprint to copy. That gap is exactly where marketing fills the void with promises it can't keep. The most extreme version of this was a device called the Q laser, sold as a cure for almost any serious disease. The pitch leaned on the fact that red light has scientific backing, which is technically true, and used that half-truth to run a massive scam. It ended with its marketer, Dr. Larry Lytle, in prison. That's what happens when legitimate science gets hijacked by bad actors. So is it worth buying a red light device for home use right now? That's your call. But if you ask me, no, not yet. These are expensive devices. The evidence for most home applications is still weak or mixed, and if your actual goal is better skin, less pain, or more energy, there are things with far stronger evidence that cost nothing: not smoking, wearing sunscreen, eating well, sleeping properly. Those aren't glamorous answers, but they're real ones. You even have a free, natural version of red light therapy available to you right now. Go for a walk at sunrise or sunset. At those times, the sun's angle filters out most of the UV rays, but still delivers that mix of red and infrared light we've been talking about. It's the original source. And the walk itself will do you good in ways no LED mask can match. That said, this is where the science stands today. Research is still moving fast. If standards get established and home devices catch up to the lab results, I'll be the first to update this and say, okay, now this is actually worth it. If you found this useful, leave a comment below. I'm genuinely curious. Did any of these verdicts surprise you? The blood sugar one still kind of blows my mind. And if you want more videos that actually dig into the science behind health trends, instead of just repeating the marketing, subscribe. There's a lot more coming, and I think you're going to like what's next.